So we have a question here that says let x or let a be this set that we have here, and probably this is supposed to be b the set that we have there. Then we're supposed to find a intersection b and a complement there. So first things first, we're going to list the given sets that we have here. So we have the first one there. We have is x is a real number such that -4 is less than or equal to x, which is less than 2 here. So that's set A. Then set B here. We have x is a real number such that x is greater than or equal to -1. Okay, so now we can just go ahead and list set A here. So because of this less than or equal to symbol that we have here, we're going to include -4 in set A here. So we're going to start from -4, -3, -2, -1, 0, 1 here. So we won't include 2 here because there's just a less than symbol that we have here. So which simply just tells us that 2 is not included there. Then for B, we start from -1, 0, 1, up until positive infinity this side. So we can just write these 3 dots that we have here. Okay, so now the first question here is saying we need to find A intersection B. So finding A intersection B here, we're simply just going to get the common elements in the two sets here. So intersection simply just means finding the common elements in the two sets there. So the common elements that we have in this set here are simply, or in these two sets here, are simply -1, 0, and 1 here. Then we're also told to find a complement. Okay, so a complement, it's all the elements that are not contained in A but are contained in the other given set that we have here. So for a complement here, we're simply just going to have elements starting from 2, 3, 4, and so on and so forth. So writing this in interval notation, or expressing this set here in interval notation, we can just say here we have our 2 here, all the way up to positive infinity like this here. Okay, let's go to the next question. Okay, so for this question we're taught to say let A be equal to -9 not included, and all the way up to 9. We also don't include the 9 there. Be the universal set. Then x be this set here that we have here. Then y be this set, and z be that set there. So let's just go ahead and list everything that we have here before we get to solve the questions there. So A here. So this bracket, the way it's written here, simply just shows that -9 is not included in the universal set there. So meaning we start from -8, -7, all the way down to 8 this side. So we can just write 7 and 8 this side. So that is the universal set. Then for x here, -1 is not included. Is not included there, so meaning that we're going to start from 0. Then 5 is included in this set, so we start from 0 all the way up to 5. So this set here we're going to have 0, 1, 2, 3, 4, 5 like this here. Then we also have z there. So for z we have -1 included, and 7 is not included there. So meaning that we start from 1, So let me just erase this. Okay, so for Z there, we're saying 1 is not included, but or 1 is included rather, but negative 1 is included, 7 is not included there. So we start from negative 1 all the way up to 6, positive 6. So we start negative 1, 0, 1 here, 2, 3, 4, 5, 6, like this. Okay, so now what to say, we need to find the first question requires us to find x complement, and then we express the solution that we're going to get here. We display it on the number line there. So then x complement is simply equal to every element that doesn't belong to set x here, but it belongs to other sets that we have here. So then we're going to have negative 8 is not in set x, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1 here. Then we won't list 0 here because we have a 0 in x. So we've got the elements in x are elements from 0 up to 5. So we won't get any of those elements there. So from negative 1, we'll jump direct to 6, 7, and 8 there. So we have 6, 7, 8 like this. Okay, so now here, if we were to write this set that we have in interval notation here, you notice that we're going to have 8 included here, comma, negative 1 also included this side, union, put together the sets there. So 6 is included here, and 8 is also included this side. So if we were to put this on the number line, we can just draw a number line like this. Okay, so I won't put all the numbers here on the number line, but I'll just write down the necessary numbers that we need there. So since it's just a sketch of the number line, so we have a 0 here, then let's say we have our 6 there, we have our 8, then there's negative 1, and negative 8 here. So now, displaying this information on the number line, because since 8 is included here, we're going to make this a solid dot here. We also make a solid dot on negative 1 on top here because it's included in the required set that we want this side. 6 is included here. 8 is also included there. So then we can just do this, and we also do that. Okay, so what we have here is a disjoint set because of these values in between negative 1 and 6 that are not included in x complement there. Okay, let's look at the next one. Or we can just erase this and do it from here. Okay, then let's also go to this set that we have here. So that's the second question there. So we have a minus x. So this simply means that that is a intersection x complement. So here basically we just list all the elements that are present in A, which is the inverse set, but are not present in x here. So basically here you notice that we're going to have elements. So here we have -8 is included in that set all the way up to -1, union anything else that's not included in X here. So that's 6 to 8. So we have 6 included there, comma 8 included as well there. So now expressing this here on a number line, which is as I think similar to what we did for the first one there. So we have our 8 here, have our 6, 0 here, -1, -8 there. So then we know that -8 is included here, and -1 is included. So we can just put a line there. Then we know that 6 is included here, and 8 is equally included there. So then we just put a line that connects the two like this. Okay, so we've displayed what A intersection X complement is here, and also we put this on a number line. Okay, let's go to the next one. So I just erase this, and we also work that one just here. Okay, so for the third one here, we have open brackets X so we have X intersection Z complement like this here. So what we're going to do first is let us list X intersection Z first, then from there we can find the complement of that set. So X intersection Z here, so we can just list the common elements in X and Z here. So you notice that we're going to have 0 there, we have 0, 1, 2, 3, 4, 5 like this here. Okay, so now writing this in interval notation, we're simply going to have 0, comma 5 like this here. Okay, so now we're taught to say we need to find the complement of the set and put it on a number line. So the complement of the set here, X intersection Z, the complement there is simply equal to all the elements that are outside this set but also contain, but they have to be contained in the universal set there. So here you'll notice that we're going to have -8 included here, and 0 won't be included. Union, we have 5 is not included, and 8 here is included. Okay, so you can just put this information on the number line there. So you can just put this information on the number line. So we have -8 here, we have a 0 there, we have a 5 somewhere here, and we have 8 this side. So then we know that -8 is included in the set here, but 0 is not included there. So for on top here, won't make it a solid dot, we just write it like that to show that 0 is not part of the set. Then here 5 is equally not part of the set, we just leave it open like this. Then 8 is a member of the set there. So we make it a solid dot here. So we have this information here and we displayed it on a number line. Okay, let's look at the next one then. You can just erase this. Okay, so for the fourth one there, we have open brackets y minus x intersection z like this. So then we're going to break down this step by step so that we can get the final thing and we present it on the number line. So here y minus x is simply y, or rather y there. Let me do this. So it's just y intersection x. So we have y intersection x complement intersection z like this here. So then here we can either try to distribute this z this side, or we can just go ahead and solve what's in the brackets there, then whatever we find we intersect it with the set z here. Okay, so now y intersection x complement here. So alright, we forgot to list our y there, so let's list y there, then we can go ahead and solve the question there. So here we have y being equal to -5, -4, -3, -2, -1, 0, 1, 2, 3 like this here. Okay. So now here x intersection y intersection x complement here is everything that's in x, but okay, everything that doesn't belong to x, then the intersection with y there. So you notice that here when we break this one down here, we're going to have this will just give us an interval from -5 up to -1 there, like this, because this is the set x that we have here. Then everything else that is outside here will contain only these elements starting from -5, -4, -3, -2, and -1 there. So meaning that this is the set that we have. Now, if we try to intersect this with the set z here, which is what we have there, which is from -1 all the way up to 7, though it's not included this side. Okay, so you notice that here what we're simply going to have is just -1 being part of this set here. So the only thing that's going to be common between z, the set z, and this set that we have this side is -1 there. So now how do we do this? We can say this here, the intersection of the two sets is just going to contain one element, which is -1 there. So we can try to write this as -1 and 0 not included here, so that we can just express this on a number line. So expressing this on a number line here, so suppose we have -2, -1, 0, 1 to this side. So we're saying 1 is included in this set and 0 is not included there. So we can just do this here. So we just tell us to say that we have 1 basically as the only element of this set that we have there. Okay, thank you.